Hello everyone and welcome to this webinar. So today we will speak about conceptual design of large assembly and especially train Carbody, and we will see how the 3D experience accelerate the innovation. My name is Martin Dreo. I'm part of the CATIA mechanical expert team, and today with me we have Anne Kozik, who is in charge of CATIA marketing. Hello Anne.
Hello, Martin. Hi, everyone.
Anne will help me with to answer the questions at the end of the webinar. So the webinar will be divided in three parts. We will start with a short introduction, and then I will perform a live demo and explaining our key technology, and we will finish with Q&A sessions. So during the live demo and even the introduction, do not hesitate to ask your questions in the question panels, or you can do it at the end as well. So let's start. Last year, we have done already a webinar where we modified this full train Carbody. So we modified different types of parameter, number of reps, global architecture configuration. We remeshed it. We restarted the simulation. And we have even seen an example of DOE where we optimize the design based on those geometrical parameters. In today's webinar, we will more focus on the modeling part, how the parametrization is created, how the modularity is prepared. So I will show and explain everything during the live demo. So we will work with this, I will come back to the start, with this sidewall subsystem of the train Carbody. We will change the architecture. We will create patterns for the horizontal ribs, and we will create the rear window by reusing an existing modules. So this is what we will do, and those type of change would take hours with the conventional processes. And here you will see that with the 3D Experience platform, we can do it in seconds. And to do that, we will mainly use three key technology of the 3D Experience platform. Concept structure, which is a solution dedicated to conceptual design of structural assembly. So it contains geometry capabilities, meshing capabilities, simulation and automation capabilities in order to test automatically the different conceptual design with the simulation. We'll also see the modules technology, which makes it possible to have a modular approach of the design. And we will use visual scripting to easily create patterns, for example, for the ribs, without any code needed. So let's start the demo. I will display the 3D Experience platform. So this is my sidewall model. So here I am on the 3D Experience platform. By clicking on the compass, I can access different apps. Right now, I am in the concept structure engineering app, and my sidewall model is part of a unique 3D part. And what we see right now is a 3D shape, and in one click, I can access the corresponding mesh. And it's not only a mesh. You see the colors are corresponding to properties, and we have as well the connections which are modeled. So here we are using shared nodes. So you see that there are no free edge between the different meshes. And if I come back to the geometry, you will see that so the mesh color corresponds to the geometry color. Why? Because the properties which are used in the mesh are directly assigned on the geometry level. So it's corresponding to the color that we see. So if I click on this part, I can access its properties in terms of material, thickness, and the type of connections which is used by default. And in one click, as I said, I can create the mesh corresponding to the geometry. So this is a parametric geometry. So I can control the global architecture of the sidewall by using those planes. So for example, I can change the length of the sidewall by moving this plane. I can modify the position of the door, and you will see how the bogie cutout and the windows is updated. And I can even change the number of windows as a parameter. So I will go from 3 to 2 windows. And by the way, this is something which is managed by visual scripting. So we will see a concrete example after. And so this is, so right now the geometry has been updated, as you have seen. I still have my previous mesh saved. And now I will just restart the mesh to update my model. And yeah, so here it will take around 10 seconds. So you can see how the mesh is getting updated. The green points are corresponding to the shell nodes. And yeah, in less than 10 seconds, my model has been updated. Okay. Now let's speak about the modular architecture of the model. So here, if you look at the tree, you have maybe icons which are new for you. Those are corresponding to the modules. So I have a modules for the planes which control the architecture of the full train Carbody and of the sidewall. And then I have a main module for the Carbody, including the sidewall. And inside the sidewall, I have also specific modules. So I will show some of them so that you understand better. So in the sidewall, I have 3 main modules: the initial extruded profile, which are here, then the cutout. So the corresponding to the front windows, the door, and the bogie cutout, and the final trim surface, which is trimming, trimming the extruded profile by using the cutouts. And now I will open the module manager so that you have a different perspective of the modular structure. So we can see the architecture, as I said, the sidewall with the 3 submodules of the sidewall that I have just mentioned. And in the initial extruded profile, I have 3 more modules. We'll come back to that later. In the cutouts, I have 1 module per type of cutout. So 1 for the door, 1 for the bogie cutout, and 1 for the windows front. And as I said, we have as well the final trim surfaces. And so the modules is not only to organize the model in a modular way. To do that, you could just organize your geoset accordingly. So it's much more than that. And the main idea is to be able to replace any module of the model by another one, and that everything reconnects automatically. So this is the main idea of the module. This other module could come from another 3D part. It could also come from a library. We will see an example later. Or it could be in the model already. So in the model, you can have alternative of modules that you can activate or deactivate, and then to be tested with a simulation, for example. So what is very important, as I said, is that the module technology is made to be able to replace the modules and to reconnect automatically. And a prerequisite to that is that the modules are watertight. So what does it mean? It means that in a module, you cannot reference an object which is outside of this module. So it means, for example, if I want to create an extrude in my wall center module, the profile I will use needs to be in the same module. It cannot be outside. This is what we call the watertight rules. And then you will ask probably, but how the modules are linked then? So they are linked via dedicated objects, which are called interfaces. And there is two types of interfaces. The inputs, so here in the module manager, I can see the inputs of this module and the outputs. And the inputs are used to reference objects which are outside of the module, and the output are used to expose objects to the other modules. So for example, if I take the door, so the door, I will display. So the door is using as input plane from the global architecture, like the Y max position, the entry floor Z max, and so on, and is outputting the curved door profile, which will be used in the final trim surface, the plane, the position of the cutout. And for example, here the bougie depends on the door position. If I change this, so here, if I change this value, we will move the door, and you see that the bougie cutout is automatically adapted. And if we look in the module input, in the input of the bougie cutout, we can see some information about the door. So those modules are communicating and are linked through the interfaces, input and output. And what's very important is that those links are based on the semantic. So it means they are based on the name of the module and of the interfaces. And this is how the reconnection works automatically. And it means as well that those naming need to be consistent, otherwise it will not reconnect. I will detail that with an example. So what we will do is we will create an alternative of wall center profile. So I will display here. So I will hide the other modules, and I will only display the wall center. So for the moment, in my wall center, I have two ribs. So I will create an alternative with 4 ribs. So tac, this new alternative, I will call it 4 ribs. Tac. And so in this, so here you see I have duplicated the initial module. And now I am starting modifying this duplicate. So my alternative, so for the moment, is the same. What I will do to add the 2 other ribs is that I will create them in the sketcher. So manually, tac. Okay. So here we see that in my new profile, I have the 4 ribs. Now let's have a look on the final trim surfaces. So for the moment, I still have only 2 ribs. Why? Because I haven't updated my interface output. So I will do that. So here in my module, as I have said, there is the input and the output. And in the output, I have the center ribs. For the moment, I have only my 2 initial surfaces. And now I will add the 2 other one. Tac. And when I will display the final trim surfaces, here I can see them. And I can switch back to my previous modules to have only the 2 ribs. So I will call it 2 ribs, by the way. And just to illustrate, so as soon as I have created this module alternative, I can switch from one to the other. And this is fully automatic. It reconnects based on the interfaces, as I have explained before. And if, for example, I modify the name of the interfaces, so like that, and I reactivate this one, I will have an issue. We don't see the ribs anymore. As I said, it's because the automatic recognition of the links is based on the semantic. So if I don't have the right names in terms of modules and in terms of interfaces, it will not reconnect correctly. So I will modify it again so that it works. And now if I activate the two RIPs again, we will see them. Okay, and now you will tell me, okay, maybe if you want to test the number of RIPs, you don't want to have a duplicate module for every number of RIPs that you want to test. And I agree with you. That's why we will create a module which will contain a pattern where we will have a parameter to control the number of RIPs. And to do that, we will use visual scripting. So first, I will create a new duplicate, a new module alternative that I will call horizontal ribs pattern. Okay. And first, I will remove. So I will hide the final trim surface. I will focus on the wall center. So I will remove my ribs which are coming from the sketch. Tac. Right. And now I will open, I will open Visual Scripting. So it's another app of the 3DEXPERIENCE platform. I can just click on the compass and open this other app. And I will, so here I will create a geoset where I will have my visual scripting design sequence. So I will call it horizontal ribs. Okay. And now the editor of visual scripting opens. So first, a few words about visual scripting. So it's a new CATIA technology to create simple or complex geometry, including pattern, without any code needed. So it's 100% visual, and I will show how to create the ribs of the pattern. I will first input the curve of my existing geometry. So in this case, I will take this curve on which I will position points. And with those points, I will create lines that I will extrude it to get my ribs geometry. And how does it work in visual scripting? So I can just use those operators, geometrical operators, and by connecting them, I will create the geometry. So here you see I have created a parameter. So maybe I will come back to concept structure. So I'm back in the concept structure app so that we see the points. So now with this operator, which divides my input curve, I can position points on this curve, and I can control the number of points with this parameter. Now, as I said, I will project those points. First, I need to input the other curve. Tac. Then I will project those points on the other curve with the right direction. Okay. And so now I have two lists of points, my initial points on the first curve and a projection of them on the other curve. And I will connect those lists with a line operator to create a list of line out of those two point lists. And here we are. And again, when I modify my initial parameter, I can parametrically change the number of lines, and this is occurring immediately. And now, as I said, to get the rib surfaces, I will extrude this line in the right direction, YZ, with the right length. So here, I'll use a very large length, and then I will split those extrude using my architecture planes. So I need to input those architecture planes. Here you see when I will click on this, even if it's part of the architecture module, as I said, modules are watertight, so I cannot use it directly. So what is used instead is an input. And you see it's an input which is in my parent module and which is here, in order to respect this watertightness rule. And I will use this plane to split the extrude. So here, take the extrude, split. Okay, and now I have the correct rib surfaces geometry. And I will assemble it, and then I will publish this geometry. So I will assemble in order to have, instead of one a list of objects, to have only one object which is containing all of them. And I will publish. And that's it. So in a couple of clicks, I have created my pattern. If I change this parameter, I can change the number of ribs in my model. And what's very important is that, like concept structure, visual scripting is not a standalone tool in CATIA. It's 100% integrated in CATIA. As you have seen, we have imported a curve and a plane from the model to base our visual script on it. And we will be able to continue referencing those rib surfaces with a conventional operator of CATIA. So it's
Excuse
not,
me.
yes,
Sorry, Martin. Someone is asking if you could zoom in on the visual part of the screen. Yes,
yes, okay,
perhaps
sure.
it will be easier to follow.
So here
Thank you
you
very
see
much.
the, yeah, no problem. Thank you, Anne. So here you see the, in zoom view of the design sequence that we just created. So there is different operator, and as I said in visual scripting, the geometry, the pattern is created by connecting those operators together. Okay, so we have published the geometry. Right now, let's have a look now on our final trim surfaces. So if I hide the X3D profile, we see again, like before, we don't see the ribs yet. It's normal. We haven't updated the interfaces, so we will do it. So in the module I'm currently working on, wall center, horizontal ribs pattern alternative, I open the output. So we see that it's not orange anymore. It's white. It means my output interface is empty. So I will add the ribs geometry that I published from visual scripting. Okay. And then based on the modules and the interfaces, it will be automatically reconnected to my final trim surfaces. So I will display it again. And here we see the ribs, which are trimmed with a cutout. So based on the modules and just the modification of the interfaces, we have reconnected this new module alternative for which we have created the pattern in visual scripting automatically. And of course, I can come back to the previous modules with the 2 ribs, the 4 ribs. But even better, now I have my module with a pattern, so I can directly change my parameter to add, for example, go from 5 to 10 ribs to add or remove some ribs. And that's how, so last time when I presented the DOE result, we had the number of ribs as parameter, and it was done like that. So now I can automatically change the number of ribs in a process with a simulation in the loop to test automatically the different design with a different number of ribs to see which design is the best, which number of ribs is the best. Yes, and to do that, of course, what is needed is to have the automatic meshing. So here I can remesh at any time after having added extra ribs. So we will see that, yeah, the mesh will be updated in around 10 seconds like before. Yeah, here we are. Okay, so I said previously that, so what we have done now, we have created modules alternative, and we are switching from one module to another using the modules alternative, which are in this very model. I said before that we could also reuse modules from a library. So now I will import in my model a new wall center alternative with diagonal ribs. So to do that, I will use the library. So I have a dedicated library for concept train Carbody, and I have different version of wall center in it. So here, the staggered ribs, so staggered diagonal ribs pattern, I will instantiate it in my model. So I just in the library, I click on instantiate. So I have a window which popped up on the other screen. And now I will choose my destination. So I will use the same destination like my other wall center modules. And of course, I need to give the right names to these modules. Otherwise, the semantic links reconnection will not work. So I call it wall center. I click on OK. And here we see that I have a fourth modules alternative, which is the one I just instantiated. And I will activate it. And I will have the diagonal ribs. And this is on the final trim surfaces. So the reconnection happened already. If I visualize the modules I imported, it looks like that. And it's reconnected with the architecture. So even if we change the length, the width of the train car body, everything will reconnect automatically, again, based on the module technology. And here I have also a parameter to change the number of ribs, which is here, similar. Can go to 4, to much more diagonal ribs. So you see the number of diagonal ribs is automatically changing. And as I said before, probably it's also possible. So in the DOE, so not only to change parameters like the number of ribs, but also to change the type of modules alternative which is used. And in the DOE we presented during last webinar, we tested it automatically design with diagonal ribs or with horizontal ribs. And that's how it works based on the modules technology. So to finish, we will create the rear windows by duplicating the front windows cutout. So I will display the cutout. So here, as I said before, I have a sum in the cutouts parent module. I have some modules corresponding to the Windows front cutout, and I will just instantiate a new version of the Windows front cutout to create the Windows rear cutout. So I select the right module destination, which is a cutout. I give the new name, which is Windows rear in this case. I click on OK. So for the moment, we have a small geometrical error because there is 2 cutouts at the same position. So what we will do, we will modify the input interfaces of my Windows rear module in order to position it at the back. So to do that, maybe I will first make it a bit bigger to have enough room for the rear windows. Okay. And so my Windows rear module like my Windows front module, is controlled by a front and a rear plane. And for the moment, the front plane, so it's here as input, it's using the front of the Carbody, and the rear plane is using a plane of the door, the front plane of the door. So what I will do, just to adapt my this to have the rear windows, I will modify those input planes. So instead of selecting the door as rear plane, I will select the rear of the Carbody. Okay. And for the front, I will select the rear plane of the door. And you see that here my Windows rear module has been repositioned by having those two planes as input. And now it's I have in a couple of clicks created a module corresponding to the rear windows, and I can modify the number of windows, for example, independently from the front one. We can also change the size of the pillars, for example. So now I have a standalone module for the rear windows. And again, based on the interfaces and the semantic links, I can still modify my patterns of ribs, and it's also connected to the rear windows. And I can still modify the number of ribs, so from 10 to 5. And this is the previous mesh I have created, and remesh the full model so that we can use it and test it in the simulation scenario. And here we see the mesh recreation. So that was it for the live demo. So I will come back to the presentation. So yeah, thanks for your attention. So during the live demo, we have seen how to create a RIPS pattern using visual scripting, how to import a module alternative from a library, and how to reuse an existing module like the front windows to recreate the rear windows. And yeah, what you those changes would take up to hours and with traditional tools. Here we have seen that we can do it in seconds with the 3DEXPERIENCE platform, thanks to concept structure, modules, and visual scripting technologies. If you want to go further, of course, you can watch the previous webinar. So here you see a teaser video where we change the number of rips, the type of rips on a full train Carbody level. We also remeshed and rerun the simulation, and we have seen some zero results. So here there is a link. We will send a link as well in the chat and per email if you are interested. And more globally, there is a lot of content on our community, so don't hesitate to have a look on that. Thanks again. I hope you liked it. And yeah, if there are any questions, I'd be happy to answer it.
Yes, there are several questions for you, Martin. And perhaps, yes, a first question is about the modules. Are there an update of the user-defined questions or concept, sorry, user-defined features concept with more visual way of interacting with the parameters? Do you understand, or should I repeat?
Yes, can you
It's
repeat,
the second
please?
question.
Yeah. Yeah, so if you can repeat, maybe I will.
Are the modules an update of the user-defined feature concept with more visual way of interacting with the parameters?
No, it's not an update of the UDF technology. It's really a new technology which is independent from the UDF. And what is new is the semantics approach and the alternatives that you can maintain in the model and that you can reuse from library. So no, it's not an update of the UDF feature that you may know already.
Okay. I think there are two other questions about modules, at least, that can be perhaps answered as a whole. The first one, how many modules are in visual scripting? How do you find the right module input-output in the visual scripting? So this is the first question.
Yeah.
And just beside, there is another person asking, at last, can you show how modules can be created and how it is useful?
Yes, so here during the live demo, so we have created modules alternative. So we mainly duplicated it from existing module, but you could create it from scratch as any geoset and connect it with the rest of the model using the interfaces. So here we have created alternatives starting from existing modules. And for the second question, the modules in visual scripting. So here, as I said, the modules are watertight. So when we used visual scripting to create the ribs pattern, so we were in the wall center modules. And as I said as well, visual scripting is not a standalone, so it can communicate with conventional objects created in CATIA. That's what we did when we used the curve. Because the curve was in the module already, we didn't use an input, but at some point we used the rear plane of the train Carbody as an object in visual scripting. And to do that, when we clicked on it, the input was automatically connected. So this is done, the inputs can be leveraged automatically when clicking on the object which doesn't belong to the same modules.
So to answer the question, how many modules are in visual scripting? There are as many as you want.
So yeah, I would depend what modules mean here. If you refer to the modules technology that we have discussed,
I guess, yes.
yeah, your visual script is located in one module, and then you can use object from the other module by using the interfaces. So yes, we could use as many modules, any object from many modules we want if needed.
Okay. A connected question, I think. How are the interfaces expected to be maintained through final design? Meaning, how is this used in a typical workflow for going from concept design through final product deployment? Is this something that Dassault has a way to link all the way through to show traceability? Or is this dependent on the end user and on our own company policies to figure out?
Yes, so that's a very good question, how to maintain the modules. And as I said, what is very important in modules is the semantic. So it means the naming of the modules and of the interfaces need to be consistent to be able to do the replacement automatically. And this is something that the user need to define by themselves because it depends on the different products. So this is those conventions and rules in terms of naming need to be defined by the users. Yeah.
So you mentioned semantics linked with the definition of the modules. Can you export these descriptions as knowledge graphs? So kind of list of triples. Is the semantics based on public ontologies?
So yeah, so it's not based on, so as far as I understand, it's not based on public ontology. So the user have to create their own ontologies. There are ways to document and export descriptions of the naming and of the links. Yes, so we have some functions to do that. Then we would need to see in details what is exactly requested. But yeah, there are some capabilities to do it.
You can export a script, but they are not triples or something like that.
So I don't know exactly what is knowledge graphs. That's why we will need to check into details if this corresponds, but there are functions to at least visualize the graph representation of the modules links.
Okay. There is a question. Sorry, I will go through questions where you can answer directly. How do the concept engineer files relate to physical products downstream? Do you understand this question?
Yeah.
Maybe will this be covered in another webinar?
Yeah, so there are different ways to do that. It also depends on the convention which are used for the modules. And I guess, yeah, we will cover that in a following webinar.
Okay. Can I assume that this functionality is only available in 3DEXPERIENCE and not in CATIA v5?
Exactly. So all what we have seen today, concept structure, modules, and visual scripting is only available in 3DEXPERIENCE CATIA, and it's not the case in CATIA v5.
Okay. So when it comes to patterns, how do you handle, for example, if you want to apply a pressure on the pattern geometry, is that possible? I mean, there will be surfaces being removed or added if you change the number in the pattern.
So, and that's exactly the point of the interfaces. So here we have an interfaces which is containing, for example, the rib surfaces. So there is one interfaces which is the connection to those surfaces. So if we remove or add ribs, so if we modify the topology of the surfaces, anyway, the pressure, for example, applied will be located on the interfaces, so it will stay stable. And this is something we can do, and we can link it in a stable way as well with the simulation. So the answer for that is modules and interfaces.
Okay. There is a question from a partner. There is a partner demo center, and are there any plans to add this concept engineering and visual scripting for train Carbody design demo to the partner demo center? Maybe we can answer this apart. Or...
Yeah, so there are no plans as far as I know, but yeah, we can discuss it later, sure.
All right, so I think, yes, I will forward you with the contact details to answer personally. All right, and can you show more ways to modify visual scripting parameters? For example, can a parameter be modified with a slider with user-defined upper and lower limits?
Yes, so it's totally possible. So in the demo, I have only shown a parameter which were located in the visual script, but as I did it for the curve, so I have inputted some curves in the visual scripting, I could also input knowledge parameters. And with these knowledge parameters, you could define lower and upper limit and step. So this could be a way to do it. And maybe even in visual scripting, we could do something similar. But definitely using knowledge parameter is completely possible.
Okay. One more question. How does this differ from parametric models?
So this is a parametric model. So the difference is that, as I said, with this new technology of the 3DEXPERIENCE platform, you can extend the capability of CATIA and of the CATIA parametric model using modules, using visual scripting. So it's more an extension, I would say, of what you have as a parametric model, and it can also very much accelerate the preparation of those models. Here we have seen that in a couple of minutes, we could create this RIPS pattern. So maybe using more conventional tools, it would take much more time.
Okay. I had myself a quick question, maybe how many alternatives do you typically need during the concept phase to test a model?
So typically, and that's the example I think we have seen last time, we can run hundreds of design alternative. So here, the idea is, of course, not to create those alternatives manually, is to prepare the parameters on the design range and then let the 3DEXPERIENCE test different alternatives on this design range by combining the parameters automatically. So yeah, we can go up to hundreds or even thousands of design alternatives if needed. And as I said, so there is an example in the previous webinar. So if you are interested, do not hesitate to watch it.
Yes, I'll enter the link in the chat, and you can find it in the LinkedIn event or in the CATIA user community post I'll show you at the end. Okay, and one last question, maybe. How long would a meshing take on a complex model?
So the meshing, so it depends on different factors. The meshing size, for example, of course, the size of the model. Yeah, during last webinar, so we remeshed this full train Carbody, and I think it took around 30 seconds for this model to be remeshed. And again, it's not only a mesh, it includes the properties, the connections and links with the simulation, which are also automatically updated.
Okay, there might be another last question. I will allow someone to talk and we'll see. So maybe you need to unmute yourself. I'm talking to the person called Nothing 015 guest or A015. Do you want to ask your question?
Hello.
Yes.
Yeah, ma'am. Actually, my question. Actually, I am joining the session later. You can send the recorded video in my mail.
I'm not completely sure I understood, but if the question was about the recording, yes, you will soon be able to access the recording. I will send it to you in the next few days. Was that?
Yeah. Ma'am, and my question is, suppose that I can, it is the complex part and a complex assembly. So how can, hello?
Yes.
Yeah, my voice is visual, sir. And my language is understand.
Sorry, I can't hear you well, and I see.
My voice is visual and my language is understand.
Sorry, I'm not sure I can understand. Did you, Martin?
No. Maybe there is an issue with the microphones.
With the sound. So don't hesitate to use. I will show how to ask further question in the community, and maybe this is something you can do as well. So if you don't mind, Martin, I will share my screen.
Yeah, sure.
Just 1 second. So I think you showed the link to the CATIA user community. So if you click if you enter, this link, go.3ds.com/CATIA, you will get here in the CATIA user community. Perhaps you will have to create a DS passport first, but it's very quick. Here you can find the posts published by Martin. Oh, sorry. It will come back. very soon. And this is where you can enter your question in the comment section. And so if any questions come to your mind later, don't hesitate to continue the conversation with Martin here. And another thing I wanted to show you is if you go to the wiki section of this community, you have a section about webinars and talks. And here is the replay of this webinar, but I will also send you the recording, and you can watch many other talks or webinar there. So that's it for me. I don't know if you have other things to add, Martin.
No, thanks everyone
All
for
right,
following
yes.
this webinar.
Mm,
Thank you, Anne, as well.
Thank you too for your live demo, Martin. Congrats, and thank you all for your participation. I'm sorry, the webinar is coming to its end, and we can't take as many questions as we would like. So don't hesitate to use the community to ask your questions if you want. And thanks, and bye for now. Talk to you soon.
Thank you. Bye-bye.
Bye.